All right, so yesterday we talked about physical changes. I told you there's two different kinds of changes. The physical change was if it changes, but it's still the same thing, it's a physical change. Today we're talking about a chemical change. This is the one I've talked about in the last couple weeks where I said, if a tree changes, does it change into a rabbit? And you guys are all laughing, ha ha ha, no it doesn't, it's still a tree, right? Well, those were all physical changes. Today, a chemical change is something like that, where it was a tree, it changes and now it's a rabbit kind of thing, okay? Yesterday, I crumbled up paper, right? It was paper. When I crumbled it up, it changed from being flat, nice sheet of paper to a ball of paper. But then I also lit it on fire. And that paper went from being paper to it changed. Was it still paper? No. What happened to that paper that was fire? What did it change into? It turned into ash. There was some smoke. And if you really look at it at the microscopic level, it actually had some water in there. Okay? So it completely changed. This is the magic. A chemical change changes what it was made out of. And here's the other key. Most of the time, or actually with chemical changes, it cannot be changed back at all, ever. Okay? So a chemical change is the process by which substances are changed into different substances with different properties. Okay? It changes and becomes something completely different. These are kind of like those magic things. I had this and it changes into this. Now, there are a couple examples that you kind of really need to know throughout the years. One of them that we did, I showed you yesterday, is when something is burned. Okay, it burns into ashes. So if I have wood, right, and I take that wood and I heat it up and I make it by fire, I light it on fire, it eventually turns ash, right? Can I take that ash and put it all back together, and even with the smallest little pieces, and put it all back together and make that wood again? No, because this has changed completely. It was wood. Now it's just a bunch of ash and smoke, okay? Some other things that does this. You see this quite often, okay? Vinegar and baking soda, okay? How many of you have done this at home before, or you've seen it on YouTube? You mix vinegar, you mix baking soda together, and you get a big bubbly mess, right? Can you take that vinegar and baking soda and somehow separate it? Like we did before with mixtures, could you run a magnet over it and pull all the baking soda out of it? Or can you evaporate all the vinegar out and then you have baking soda left? No, because once those two get together, they did something called a chemical reaction, and they mixed to the point where they changed completely. There is also, there is the perfect way to figure out if something has really changed chemically, okay? Now, sometimes you can look under the microscope and say, okay, it was this and now it's this. But how many of you have a microscope at home and you're able to take things and you're able to look at those microscopic pieces? No, because the microscopes you have aren't strong enough to look at the tiniest little pieces it's made out of, okay? When you have a chemical change, the actual building blocks, you remember the atoms, the Legos we've talked about before, those things actually completely change. So how do you know if there was a chemical reaction? Well, there's a couple things, and I'm going to tell you right now, if on your test or on your quiz or somebody in real life says, was this a physical change or was this a chemical change? The first thing you should do is see, did one of these three things happen? Did something change temperature? Okay? And I'm not saying like, oh, I lit it on fire and that made it hotter. No, we're talking about we mix two things together and all of a sudden it just gets really hot. Or we mix these things together and it gets really cold. Okay? Another thing is right here. With baking soda and vinegar, I put it together, right? And what happens? It makes a bunch of bubbles. Bubbles is actually what? What is it actually making? Scientific vocabulary word that you just learned in the last day or so. what does it actually make? I have this vinegar, I have this baking soda, I make it together, and all of a sudden I get a bunch of bubbles? What are bubbles, actually? No, mixture is putting them together, right? That's your mixture. I put them together, and when I put it together, it actually forms these bubbles. What are bubbles? No, what are bubbles? What are bubbles made out of? What are bubbles? Which is a gas. So look at this. I mix a solid and a liquid together, and all of a sudden I get a gas. Bubbles is a perfect example of forming a gas. So if you ever mix two things together and all of a sudden it starts bubbling, or you see a gas of some kind and you see something blowing up, like if you put it in a balloon and the balloon starts getting bigger and bigger, that means it's making gas. So if it changes temperature, if it makes a gas, or it changes color, then there's been a chemical reaction. For example, we live here in Florida, right? In the fall, winter time, we have all these trees around here, right? And they have all these little green, hard, little round things on them, right? And if you wait a couple months, all of a sudden they magically change into orange, round things. It changed the color, right? It went from green to orange. Does the orange tree say, hey, it's time to change colors? Is there somebody out there painting those colors? It changes on its own because it is changing chemically. Have any of you ever tried to eat a green orange?
Ew.
Yeah, I heard, ooh, yeah, it's sour, right? But there's a chemical change that happens over a couple months that goes from being a sour, green, hard rock-like fruit to a very sweet orange. It's changed color. So when we're talking about all these different changes, it's real simple, guys. If we mix two things together and it makes bubbles or makes some kind of a gas, that is proof that there was a chemical change, okay? Or, here's again the color change. I have fried green tomatoes and then they turn into red ones. Does it just magically do that? No, but it has completely changed from being that gross green tomato to a red, ripe tomato. Now some of you are saying, but it was a tomato before and now it's a tomato again. Is it a tomato? Is that what tomato you think of when you eat a red tomato? Are they the same taste, the same texture, the same everything? No, so it has changed. We still call it a tomato, but it has changed. Another one, if it changes temperature on its own. And I don't mean, ooh, I add hot water to it and all of a sudden it gets hotter. No, okay? It would be like if I added hot water to it and all of a sudden it gets really cold. Or it does some kind of temperature change you're not used to. Have any of you used these hand warmers? Yeah, it gets cold outside. You got these little pouches, right? You take it out of the pouch and you shake it up. Well, you're mixing two little chemicals in there. What happens when you mix those two little chemicals? It's all of a sudden starts getting hotter and hotter and hotter. A lot of hunters use them. If it's a cold day, you put them in your pockets and you walk around with these nice warm hand warmers. Is it going to get so hot that it's going to burn you? No. But it is changing temperature on its own. I didn't like light a fire on it and all of a sudden say, ooh, it got hotter. Okay? It is, I mixed these two things together and they got hot. Sometimes you could do it the other way, mix two things together and it gets really, really cold. Anybody know of an example of something that we mix together and it gets cold? And I don't say, well, I put ice cubes in a drink. I know, ice cubes will make it get colder. Okay, but what will happen to those ice cubes? They're going to get hotter. So we're actually meeting in the middle kind of thing. I'm talking about taking two room temperature things, putting them together, and all of a sudden they get really cold. Ice packs, that's the one I'm thinking of. Have you ever seen those? Like the firemen have or whatever. They have this little baggie of things and somebody's been in a car accident or something and they get these little baggies out and they break it and they shake it all up. And then all of a sudden it gets really, really cold and they put it on their arms or their legs or whatever. You guys know what I'm talking about? Those kind of ice packs. I'm not talking about the ice pack you put in the freezer and let it get cold and then you pull it out. I'm talking about the ice packs that you mix these two chemicals together, okay? So we have, If it makes it bubbles, if it makes some kind of a gas, that proves there was a chemical change. If it gets hotter, it proves there's a chemical change. What if it changes color? It's about to get time here real soon where all of a sudden you guys, most of you guys, within the next month, will get something where you mix two things and it changes the color. You have any idea what I'm talking about? Nope.
Eggs and the color water.
No. What's at the end of this month? What's at the end of this month?
Halloween.
Halloween. What do you have at Halloween that most of you will take and you are going to mix two things and all of a sudden it changes color? Glow sticks. How many of you have used a glow stick, right? What do you have to do? You have to break it open, and what happens? There's a little piece of glass vial of something in there, of some kind of liquid, and it mixes with another liquid. And what happens when those two mix? It changes a color, right? It was clear, two clear liquids, and now all of a sudden it's a bright glowing yellow, red, whatever color it is. Okay? That's because it was a chemical change. Can you take that glow stick and pull those two different colors back out, those two liquids back out? No. Because on a chemical change, once you mix it, you are not going to be able to pull it apart. Okay? For example, you guys have all made pancakes, right? You mix up flour and eggs and milk and all that good stuff, right? You mix it all up and you put it on the griddle. Right? Is that a chemical or a physical change?
Chemical.
Chemical, okay. How can you prove it was a chemical change? Okay, so it changes color because it went from being that white color to the golden brown, right? What else? Okay, one, we'll come back to that, but how else can you prove it?
Like shape.
No, not changing shape. Changing shape is a physical change. How else can I prove it's a chemical change? One is it changed color. No. Have you ever cooked them? What happens when you're cooking them? When you're looking at that batter, that pancake batter that's sitting there. They're what? They're bubbling, which means they're making a gas, right? So that proves that this is a chemical change. If it changes color and it bubbles, those are proofs. Now, a lot of you kept saying, well, you can't take it back. You're absolutely right. If I make a pancake, can I somehow, some way, some shape, separate it and get my egg back out? And somehow get my milk back out of it and my flour? No. Okay? So, when we're talking about chemical changes, we are talking about things that have changed and they change completely what they were made out of. Okay? It's not like when I took peanuts, crushed it up, and made peanut butter, and it was peanuts before and it was still peanuts. We're talking about if I were to take peanuts, crush it up, and mix it with something, and all of a sudden I now have a rabbit. Okay? That is a chemical change. That is completely changing. How do I know it has changed? If it changes color, if it makes bubbles or a gas, or if it changes temperature on its own. That proves it was a chemical change. The other thing is, chemical changes, you cannot change back, ever.